Hello friends, I am Chandan. This is the second lecture of first law of thermodynamics. So next, our topic is enthalpy. So enthalpy is basically system's thermal energy which is available. The system, suppose this is our system. So in this system, the total thermal energy is available in this system is known as enthalpy. Basically, uh, enthalpy H is equal to U plus PV. So in enthalpy, in control volume analysis for steam turbine, the scientist Moulier feel that the term U plus PV appears frequently, and for conveniences, this term is known as enthalpy. Okay, so enthalpy is basically U plus PV. Enthalpy is equal to H equal to U plus PV, and the unit will be kilojoule. Now, if you divide it by mass, so this internal energy will be specific internal energy P small v, that is equal to H. So this is the enthalpy H equal to U plus P small v. So the unit will be kilojoule per kg. So enthalpy is basically system's thermal energy. Okay, now next topic is that heat transfer for different process. So if it is a constant volume process, so if you see the constant volume process, this is the PV diagram, and if the process is like this, so here pressure is increases, then this is a heat addition process, and the second process 1 to 2 in downward direction, the pressure is decreases, that means it is a heat rejection process. Now you know the formula, that is del q, that is equal to du plus del w. So for a del w, for a closed system, del w, that is equal to pdv. Okay, pdv. So this equation is applicable. So del q, that is to du plus pdv. This equation is applicable only when it is a closed system, reversible process, cross boundary, and change in kinetic energy and potential energy are neglected. So this is a constant volume process. So that is why this is equal to 0. So from here, del q, that is equal to du. And du, basically du, change in internal energy, this is du. The formula of du, that is equal to mcv dt. So dq, del q, that is equal to mcv dt. So this equation is applicable only when, this is very important. This is very important. This equation is applicable only when it is a closed system, reversible process, cross boundary. Cross boundary means heat and work can transfer through the boundary. Okay, and change in kinetic energy and potential energy are neglected, ideal gas. So if this condition is there, then you can apply this formula. So del q, that is equals to mcv dt. This is for constant volume process. This is for constant volume process. So by joules for ideal gas, so du, internal energy is a function of temperature. Internal energy is a function of temperature. So the formula is du, that is equal to mcv dt, and dh, enthalpy, change in enthalpy, dh, here this is h, this is h, dh, that is also function of temperature. So dh, that is equal to mcp dt. Remember this is mcp dt, mcp dt, dh, that is equal to mcp dt. Okay, now focus on the constant pressure process. If you see, this is a PV diagram, and if this process will be this, that means volume is increases. Here this is the initial volume, and here this is the final volume. So here volume is increases. So if the volume is increases, then it is a heat addition process, or if the volume is decreases, this is a heat rejection process. Now you know the formula first of thermodynamics, that is del q, that is to du plus pdv, and del q, that is to, you know the du, that means m cv dt. So m cv dt plus pdv. So we know that h equal to u plus pv. So from here you can say that dh, that is equal to du plus pdv plus vdv. H pressure, that is equal to constant, so that is why this derivative will be 0. So from here, du plus pdv, you know that du plus pdv, that is basically dh du plus pdv, this is basically dh. So you can say that del q that is equal to dh. So from this equation here, del q uh, uh, del q that is for du plus pdv, here del h that is for dh plus pdv. So from here you can say that del q that is equal to dh. From here you can say that del q that is equal to mcp dt. Very very important, very very important. So del q that is equal to mcp dt. So dh that is equal to mcp dt. Now from here you can conclude that here hence in case of constant volume process for uh, closed system heat transfer is equal to change in internal energy. So here from here heat is transferred, so del q that is equal to mcv dt. So basically what is given, that is heat transfer. So here heat in case of constant volume process for a closed system, heat transfer is equal to the change in internal energy. And in second del q that is to mcp dt. So here hen hence in case of constant pressure process for closed system, heat transfer equal to the change in enthalpy. Okay, heat transfer is equal to change in enthalpy, change in enthalpy, and here change in internal energy. Acha. Okay, now in the above two cases, heat transfer behaves like a property or point function. Okay, so that is why you can say that heat is a transient function. This is very very important. Heat is a transient function. So transient means heat is a path function and it is also the point function. So that is why you can say that it is a transient function. It is a transient function. Transient function. It is a transient function. Okay. Now focus on the isothermal process. Isothermal means constant temperature process. So here if you see the PV diagram, so this is the process, heat rejection process. Here pressure is increases and volume is decreases. That is a heat rejection process. And here uh, uh, here that is volume is increases. That is heat addition process. Now if we saw the first law of thermodynamics, that is del q that is equals to du plus del w. So du that is equals to mcp dt. So as the temperature that is equal to constant, so the derivative of the dt that is equal to 0. So from here this term is neglected. So from here del q that is equal to del w. We know the formula del w for isothermal process, that is mRT ln v2 by v1, or you can say that mRT ln v final by v initial. So this equation is applicable only when it is a closed system, reversible process, ideal gas, change in kinetic energy and potential energy are neglected, and work process boundary. Okay. Now, so this is the formula, very very important. You can remember this formula, del q that is equal to mRT ln v final upon v initial. Okay. Now focus on the adiabatic process. Adiabatic process means no heat transfer. Q is equal to no heat transfer. Adiabatic process means no heat transfer, that is Q equal to 0. From here Q equal to 0. So that is why this is 0. So du plus del w. So del w adiabatic that is equal to minus du. You can say that. So hence work done becomes property for adiabatic process. Therefore work is also a transient function. So here this is transient function because it is a point function and it is as well as it is a path function. So that is why you can say that it is a transient function. It is a transient function. It is a transient function. Okay. Now focus on the polytropic process. Polytropic process, that is there is no assumption P v to the power n that is equal to constant. So there is no assumption. So del q, you know the formula, del q that is to du plus del w. So del q poly, this is applicable for polytropic process. So del q poly that is equal to mcv dt. You know that formula du that is equal to mcv dt plus polytropic work, you know the polytropic work, that is P1 V1 minus P2 V2 upon n minus 1. Okay, so from here del Q polytropic is equal to so what is the value of CV? Remember the CV value. CV is equal to R upon gamma minus 1, and CP formula gamma R upon gamma minus 1, and CP by CV that is equal to R, and CP minus CV that is equal to R. So CP by CV is equal to gamma, CP by CV that is equal to gamma, and CP by CP minus CP that is equal to R. This is valid for ideal gas. So remember this data, very very important. So from here CB that is equal to CB that is equal to R upon gamma minus 1. So MR upon gamma minus 1. Delta T minus means T2 minus T1 plus P1 V1 minus P2 V2 upon n minus 1. From here, if you common, so from here you can get this term. So from here, del Q polytropic that is to gamma minus n upon n minus 1 into gamma minus 1 P1 V1 minus P2 V2. So if you consider that from here you can get del Q polytropic that is to gamma n upon gamma minus 1 del W polytropic. So del W polytropic, you know the formula, del W polytropic, that is P1 V1 minus P2 V2 upon n minus 1. So this is the del W poly, and from here you can get the formula that is del Q poly that is to gamma minus n upon n minus 1 into del W adiabatic. So del W adiabatic will be P1 V1 minus P2 V2 upon gamma minus 1. Okay, so this is the formula, very very important. Now for polytropic specific heat, so focus on polytropic specific heat. Del Q polytropic that is to MC poly dt. Okay, so del Q polytropic, what is the formula? Gamma minus n upon n minus 1 into gamma minus 1 P1 V1 that is equal to MC poly T2 minus T1. From here you can get the formula C poly that is equal to gamma minus n into R upon n minus 1 into gamma minus 1. So this is the formula of C poly. C poly will be negative value, because gamma minus n is the negative value, and here gamma minus n is the negative value, R is the positive value, n minus 1 is the positive value, and gamma minus 1 is the positive value. So that is why C value will be negative. Okay, so this is my handwritten notes useful for GATE, ESC, ISRO, DRDO, BARC and other competitive exam. The PDF link is given on the description. You can download it from the given link. There is a Telegram group you can join for GATE time to time video. Okay, if you have any question you can message me. There is a comment box, you can message me. Okay, thank you. Like, share, subscribe my YouTube channel. Thank you.